friends, welcome to my channel Nidhi Bhasin Mathematics Classes. Today I will be discussing tips and tricks using magic hexagon for trigonometric identities. And this video is in continuation of my last video in which I had shared with you tips and tricks for learning trigonometric functions. So let's get started. I will be taking this hexagon as my magic hexagon for learning various trigonometric identities. Now I will tell you how I can use this hexagon to study various trigonometric identities. We know that tan theta is equal to sin theta upon cos theta. This will help me to write the names here. There are few rules which we will follow for writing the trigonometric functions here. One, I will be following this rule tan theta sin theta upon cos theta starting from this point. How I will name this? Tan theta is equal to sin theta upon cos theta. First thing you have to remember while naming the trigonometric function in this hexagon is tan theta will start from here and tan theta is equal to sin theta upon cos theta. The second thing which you will remember is all the trigonometric functions starting from C will come on right side of hexagon. On right side of hexagon. Now, opposite of tan is cot. So what else is left in trigonometric functions which are starting with C is cosecant theta. So which function is left among all 6 trigonometric functions? Secant theta. So that I will write here. So how I started? This point I will start with tan. And why did I give you this formula? So that you can understand by having a relationship. Tan theta is equal to sin theta on cos theta. Inverse of tan theta is cot theta. And what else is left on this side of hexagon which is starting with C? Cosecant. So cosecant will come on this side. And only secant was left, so secant will have this position. These positions are fixed, you can't change them. If you want to use magic hexagon, these positions of trigonometric functions are fixed. Now I will be joining their diagonals. And I will be writing number 1 in the center. So this completes my magic hexagon. The first group of identities which I am explaining using magic hexagon is quotient identity. And I will be giving you 12 identities by learning only this, that first function is equal to second divided by third function. And I will be taking this 6 times clockwise and 6 times anti-clockwise. And that will give me 12 quotient identities. Only by learning this only, that first is equal to second by third. So if I start from here, we normally start magic hexagon from tan theta. So let's start from here only. Tan theta is equal to that I will be writing in front of you. Tan theta is equal to sin theta upon cos theta. Why? Because this is first and this is second and this is third. So first is equal to second by third. Now I am taking sin theta, cos theta and cot theta, these three. So what will be my identity? Sin theta is equal to cos theta, that is second, and cot theta is third. So this will give me sin theta is my first function, cos theta is my second function, cot theta is my third function. Now I am taking the same on these three. So what it will be? It will be cos theta, second by third, that will become cot theta upon cosecant theta. If I am taking from these three, from cot to secant, then what it will be? It will be cot theta equal to cosecant theta upon secant theta. You can try solving this, in every way it will hold true. Now in last, cosecant, secant and tan, what it will be? Cosecant theta will be equal to secant theta upon tan theta. So how many you have got till so far? 1, 2, 3, 4, 5. One is left. What is that? Secant, tan and sine. So I will be taking secant theta will be equal to tan theta upon sine theta. So this was only from clockwise direction. I was getting 6 trigonometric identities. Now I am using this on this figure in anti-clockwise direction. So what was my method? First is equal to second by third. So I am starting from cos and I am going towards this direction. So cos theta will be equal to sin theta upon tan theta. First is equal to second by third. Same way I am taking sine, tan and secant. Then it will be sin theta equal to tan theta upon secant theta. Then I am taking tan theta, secant theta and cosecant theta. That it will become tan theta equal to secant theta upon cosecant theta. Then I am taking secant, cosecant and cot. So it will become secant theta equal to cosecant theta upon cot theta. And next is cosecant, cot and cos. So it will be cosecant theta equal to cot theta upon cos theta. What is left? Cot, cos and sine. So what it will be? Cot theta will be equal to cos theta upon sine theta. Now I will be taking product identities using this magic hexagon. How did we name trigonometric functions in this magic hexagon? We started from tan. Tan is equal to sine by cos. All the p's will come on right side. We will join the diagonals and we will write 1 here. The other thing which you have to remember in this magic hexagon, these arrows. For what type of identities you are remembering, you need to remember these arrows. Now I am taking product identities using these 2 magic hexagons. In which, what is the difference? Only the difference is in arrows. And you will get 9 identities from here. Now, let me start with the first figure in which I am taking functions at diagonally opposite vertices are multiplied. How? These two are diagonally opposite. These two are diagonally opposite. These two are diagonally opposite. And they all are coming towards 1. So how I will be writing? I will be writing sine theta into cosecant theta is equal to 1. Tan theta into cot theta is equal to 1. Cos theta into secant theta is equal to 1. So I got 3 identities from this magic hexagon, in which I have to remember only this thing, that the functions which are at the opposite vertices of the diagonal, their product will be 1. So this one is acting as the answer of these two. Now in my second figure, what is the difference? Only difference is in arrows. Rest all trigonometric functions are same. So in this case, I am taking in any 3 continuous functions, first into third will be equal to second. I am taking these 3 continuous functions, tan, sine, cos. So what is my first one? This is first, this is second, this is third. So can you see this arrow? From this I am getting tan theta into cos theta is equal to sine theta. Can you see that? Tan is going towards sine, cos is coming towards sine. So tan theta into cos theta is equal to sine theta. Now from this, if I take sine, cos and cot, I am taking sine, cos and cot. So sine will go towards cos and cot will also go towards cos. So what is my answer? What is the second one here? Second one is cos theta. What is the first one? Sine theta into cot theta. Now in my next relation, I am taking cos, cot and cosecant. So what is the answer? Answer is cot theta. Why? Because in these 3 continuous functions, this is first and this is third and this is second. So second will come here, first will come here and third will come here. Cosecant theta. Understood? Now I am taking cot theta, cosecant theta and secant theta. From these 3, this is acting as my second one, this is first one, this is third one. So the second one will come here. I am separating out second one so that you can easily write first and third here. Cot theta into secant theta. Now if I take cosecant, secant and tan, which one is in the middle? Secant theta. So which two I will take? Cosecant will be first and tan will be second. Now the last one which I am taking is secant, tan and sine. So what will be? Tan theta will be the second number and this is first into third. So first trigonometric function is secant theta and the last trigonometric function is sine theta. In CoFunction identities. In CoFunction identities, we will take care of these arrows first. These arrows will be going towards this direction in all 3 cases. Now other thing which you need to remember will be angle A plus angle B is equal to 90. You remember which 2 angles are complementary. If their sum will make a sum of 90 degree, then those two angles are complementary. So two angles are complementary if their sum is 90 degree. So remembering this, I will be finding, if I have to find angle A, what will be? It will be 90 degree minus B. So I will be taking sine here. Is it clear? Sine theta here, and whatever is pointing towards that side, that will come with 90 degree minus theta. So sine theta will be equal to cos of 90 minus theta. Tan theta will be equal to cot of 90 minus theta. Secant theta will be equal to cosecant 90 minus theta. Now I am taking reciprocal identities. Now in this, what I have to remember, that functions at diagonally opposite vertices are reciprocal of each other. What did it mean? That this is the diagonal. Whatever functions are there on the opposite side, they are reciprocal of each other. So there are three diagonals, 1, 2 and 3. And this follows vice versa. I will go sine theta is equal to 1 by cosecant theta, and cosecant theta is 1 by sine theta. Same way, tan theta is 1 by cot theta, and cot theta is 1 by tan theta. Same way here, cos theta is 1 by secant theta, and secant theta is 1 by cos theta. So three functions I have already written. I have written sine theta, which is 1 divided by cosecant theta. Tan theta, 1 divided by cot theta. Cos theta, 1 divided by secant theta. So in this direction I am following. Now if I come opposite, then what it will be? Cosecant theta will be equal to, if I am going in this way, cosecant theta will be 1 upon sine theta. Secant theta, if I am going from secant towards cot, then secant theta will be equal to 1 upon cos theta. And if I am coming from cot towards tan theta, cot theta will be equal to 1 upon tan theta. So you have got 6 reciprocal identities. Now I am taking Pythagorean identities. They are the ones which are difficult to learn, and mostly students have problem in learning these Pythagorean identities. But it will become very simple for you using this magic hexagon. Now in Pythagorean identities, I will be taking triangles, one time clockwise and one time anti-clockwise. And which three triangles I will be taking? I will be taking this first triangle. This will be my second triangle, leaving this one. I am not taking this. I am not taking this. So I am leaving this. I am taking this as my third, and I am leaving this. Understood? So in these first, second and third triangle, I will be going in clockwise direction. My arrows are pointing in clockwise direction. Now you have to remember one thing, that whenever I am pointing my arrow, it is going from left to right and then towards south. Understood? Left to right and then towards south. Left to right and towards south. South is, you know na? This is north and this is south. So this is facing south, this is facing south, this is facing south. And for anti-clockwise, I will be taking again these three triangles, and now my arrow will be starting from the function which is facing towards south, and my arrows are moving from right to left. Starting from south, a trigonometric function, right to left, right to left. And other important thing which you have to remember, while writing clockwise, trigonometric identities, for Pythagorean identities, I will be using plus sign, and while writing anti-clockwise, I will be using minus sign, and it will come before the second function. And in Pythagoras, you know that in Pythagoras theorem, we take the square of perpendicular square plus base square is equal to hypotenuse square. So we will take square of the trigonometric functions here. Now I will be taking first triangle, this one, in which I am writing sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. Next I am taking this one. I am starting from 1. I am going towards cot and then towards cosecant. So 1 plus cot square theta is equal to cosecant square theta. Last one, this one. I am starting from tan. I am going towards 1 and ending towards secant theta. My arrows are facing south, and the trigonometric function which is facing towards the south direction in a triangle will be the one which will be towards this side. So tan square theta plus 1 is equal to secant square theta. Tan square theta plus 1 is equal to secant square theta. So 3 trigonometric functions I have got from the clockwise direction, and 3 I will be getting from anti-clockwise. Now for anti-clockwise, I will be writing minus sign before the second trigonometric function. Now in this triangle, I am taking anti-clockwise. So 1, starting from 1 minus cos square theta is equal to sin square theta. And then I am taking this triangle, cosecant square theta minus cot square theta is equal to 1. Then this triangle, secant square theta minus 1 is equal to tan square theta. So this is the short way of remembering the trigonometric identities. Thank you for your support. Please like, share and subscribe my channel, Nidhi Bhasin Mathematics Classes. Please practice this magic hexagon 2-3 times at least, and I will be coming with the tips and tricks for drawing the trigonometric table in my next video. Keep learning, keep sharing. Thank you.